we have many different languages that we use at Bloomberg, and we use F# for certain purposes. However, today what I'm going to present you is how we use OCaml to solve a specific set of problem, and how it has helped us a lot to to develop better software. So really, for those of you who don't know Bloomberg, see, this talk is in New York, it's much easier. So there's a few things that we do. The number one is the Bloomberg Professional Service. That's what is called a terminal. That's a piece of software that essentially sits on 300,000 financial professionals around the world. They all connect together. They all use our tool to make financial decisions based on the analytics and the data that we provide. We also have media services, industry solution, and enterprise solution. So this is how the terminal looks like. Tons of data, tons of analytics. It's a bit like the web, tons of websites. Inside the terminal, you have access to a large amount of functionality. Okay. What about the R&D at Bloomberg? So Bloomberg is at around 15,000 employees, and we are 2,000 developers. That's quite a big number. And so where is OCaml, being used out of those 2,000 developers? Well, so there's a smaller group, which is called the derivative group, which deals with a very particular type of financial contract. We'll see later some example of those financial contracts. And that's about 200 developers. And inside this group, we have about 20 developers that are on a regular basis touching OCaml code base. Now, there are many other languages that we use. C++ is definitely one of them. I think we have a very large code base of C++. We have C++ expert. And one of our role actually in the group of OCaml enthusiasts is to make sure that a lot of the software that has been developed using C++, we integrate it and we make it like one ecosystem, right? And there's a lot of other language, JavaScript, OCaml, F#, and some that I don't even know. Okay, so now what are the problems, the concrete problems that we are trying to solve? So people out there are doing what we call a derivative contract, over-the-counter derivative contract. What it means is that they're essentially signing on a piece of paper rights and obligation. It's pretty much the same concept as when you have a mortgage and you agree with the bank and there's a list of like contractual obligation, some very simple, some very complex. You agree, that's it, it's between you and the bank. And then what do? We try to provide independent analytics on those financial contracts. Okay, so this is our role. People go to the terminal, they enter the contract detail, and we tell them independently from whoever they buy it from what the value is, analytics, exploring the contract, understanding how it works. We give them insight on those derivative contracts. And we do two things. The first thing we do is deterministics things. So purely based on the definition of the contract, we try to explain it, do some analysis, show possible scenarios, and then we also do some stochastic analytics. So all of those derivative contract depends on underlyings, which could range from anything. So the most simplest one are usually equities, like IBM stock. And so what do? We try to simulate the value of IBM, and we provide stochastic analytics on the derivative contract that depend on IBM. And why this problem is extremely complex? So, okay, so before we do that. So why is this extremely complex? It's because you have only one IBM stock. However, out there are probably hundreds of variations of OTC contract on IBM. So you can see now you take all of the possible companies, all of the possible asset classes, interest rate, commodity, oil, gas, weather, and people are making contracts on top of those observable values. So the universe is huge, right? And so this is a problem for us as software engineers, is because how do you represent this? So everything, now where OCaml started. So basically 3 years ago, we did a partnership with a company from France called Lexify, We partnered with them and we integrated a very core library that they have developed around financial contract. We've worked with them in integrating it, and we extended it and we integrated it inside our software. So why those financial contracts are a challenge is because there's so many of them, hundreds of variations. So if you look at, and the problem as well is that the ones that are highly traded, there's a few number of them that are highly traded. However, there's a lot of them that are not highly traded, but that we still want to provide analytics for. So we are an independent company, right? So if Bank A is making 10 products, Bank B is making 10 products, Bank C is making 10 products, we want to do all of those products. So our universe is trying to cover everything from every bank. So really, this is a challenge for us. And the number one challenge is trade capture. So all of those contracts have parameter. They have a name, and they have a parameter associated with them. And when you have 100 of those, how do you do this? Right? You need to create 100 screens to do those kind of things, to capture the information. So it's not new. We've been doing this for 15 years now. And at the beginning, well, we did not use OCaml, and we used C++. And so, well, what do you end up doing? You end up creating hierarchies. So you have a high-level representation of a financial contract, and then you try to create a type hierarchy to represent all of the contract and trying to do code reuse using hierarchy. Okay, so that's one representation of a financial contract. Then you have to create a UI in order to capture the data, right? Basically the parameter of the constructor. Okay, so you have a UI abstraction layer that defines your widget, and you do mapping from one to the other. That's some code. And then you have a concrete UI, right? We have many different UI technology at Bloomberg. They keep evolving. So you also do the mapping here. Okay. So now, as you can see, if I give you 100 contracts to implement, you're going to have to write all of this code, and you can quickly see that it's not going to scale. Right? All right, so how did we tackle the problem without OCaml, but trying to minimize the amount of code that we were doing? So the story was like we tried to use an independent type system, and we used the schema XSD. It's something that we already use quite a lot at Bloomberg, and then we wrote our own code generator on the time to try generate the various types, both the UI and the business representation, and to automate the mapping between them. Okay, so that was a good step. However, it's quite complicated. As you can see, there's a lot of moving part, right? You start with the XSD, it's language agnostic. Then you have to write a code generator. That code generator was actually written in Ruby. Then it generates C++. And it generates the mapping from one type, from one generated code to another. Quite a heavy machinery. However, it worked fairly well. Like we were able to scale our system a lot more rapidly than before. Okay. Now, third iteration comes OCaml, right? And the partnership with Lexify. So OCaml, one of the greatest things about OCaml is the type system. It's a lot more expressive. You can represent data with a lot less invariant. You have a better tool at your disposal. So the idea was to use a slightly modified version of the OCaml compiler to get runtime type information. And using that runtime type information, you could actually generate a UI representation. From this, you would do only one-time code, which transformed the UI representation to the proprietary UI toolkit. So really, the code here is much smaller. All you have to do is write one time the mapping, and after that, leverage the OCaml type system to actually represent both your contract as well as the screen. And that worked really well. So that allows us to scale a lot more. We could now create new financial contract in a matter of days. rather than months, right? So that's a big win for us. But that's not the only problem that we have with financial contracts. So now imagine that if I give you 100 contracts and they all have a name, and then we all agree about what the name is, and then you have your own idea about what the contract is, and I have my own idea about what the contract is. And all we share is really the type, right? The actual parameter of the contract. But what happens is that people have different understanding of those contracts. It's not, it's very ambiguous, right? It relies on a common understanding, and that's not good. Right? We want to have a formal representation of contract. So really here, we see that even though we made progress with the type, that means we formally define the input of a contract using the OCaml type system, still, the problem is not fully solved because, it's not enough, right? So let's look at actually a very concrete financial contract out there so that you can see a little bit the type of contract we are talking about. So this is an article about a year ago, which was entitled "Portuguese Train Company Was Run Over by a Snowball." And it was mentioned that it was one of the worst trade of all time. So what is it? So like I said before, a financial contract is something that you exchange money, right? So here, what do we have? We have two counterparty. One was the bank, the other one was a Spanish train company, okay? And they did this contract, meaning that the bank is gonna give a fixed amount of money every quarter to the Spanish, the Portuguese train company. Okay, and in exchange, the train company is gonna give a variable amount of money to the bank. So far, so good. Okay, but the question is really what is give rate, right? What is this variable amount of money that the Portuguese train company agreed to pay? So first of all, let's look at the variables, right? So there are two variables. The first one is called the Euribor 6 months. That's pretty much the rate that banks exchange euro. Yes? Yes, exactly. So that's the rate at which banks exchange money for a 6-month period of time. Okay, and so every day, all the banks, they agree this is the number. So every day you get a new number and you can observe it and you can make a formula on top of it. Then you also have another variable in this function, which is the previous rate. Okay, so what I'm paying today depends of what I paid you, the quarter before. Okay, so far, so good. Okay, so this is what they actually agreed on a piece of paper. Right, this is the financial contract they agreed on. So they say the coupon rate is gonna be the max of 0, coupon rate from the previous period, plus a spread. All right, so here, what is the spread? So if the Euribor is above 6%, then you take the difference between what it's above 6% and you multiply it by 2. Same thing if it's below 2%, you will take the difference and multiply it by 2. But if it's in between 2 and 6%, you actually subtract 0.5. All right. This is real. So obviously there is a good situation, right? Is if it stays between 2 and 6%, that's it. You're good. You never pay any money. You keep being at 0, no problem. Life is good. So when they actually bought the contract, that's what the history of Euribor 6 months was. Except for one tiny day, one date. It stays between 2 and 6%. So this is what they see. Wow, it never went outside of this boundary. So this is free money. They give me a fixed rate. I give them 0 all the time. Okay, but this is what happened. A couple of years after they buy the contract, financial crisis happened. The interest rate dropped drastically, and now you enter into a massive fault left aggregation of the contract and the coupon rate, and boom. So what happens is that they ended up paying, I think they stopped paying after a while. It reached 30%, and I think that technically if the euro, and it's still below 2%, if it keeps going like this, they will pay 100% by 2017. Right. So obviously they needed tools to understand what they were getting into. Right. That's and okay, we're programmers. We actually understand this very well, right? This is code, and this is really the key idea, is that they bought a financial contract, which really is a piece of code, right? So we are programmers. We are functional programmers. So what do we learn? What do we know? Well, we know how to express a little a little algebra, right? So this is OCaml code, but essentially here is a little algebra. This is how we start writing our own little language. We define an expression, constant, plus, minus, multiply, recursive type. Beautiful. We introduce variable. This is what we know. So the whole idea is that this paper 15 years ago was done by Jean-Marc Hébert and Simon Peyton-Jones and Julian Seward. And Jean-Marc Hébert is the founder of the Lexiphi company. The whole idea was like, okay, we have an algebra for math. We know that very well. How could we extend it to represent the formula that I just described you before, right? And if we manage to do so, well, then we can start doing all the cool things that we do with program. We can compile them, we can analyze them, we can make them simpler. You know, those are the things we know how to do. So here is an example where we introduce a function called cash, which is takes a date, takes a number, a currency, and gives you a contract. Okay, so you have a fundamental type called contract. What can you do with it? Well, you can do the things that we love to do in algebra. So we can do AND and OR. So what is an AND? So if I give you a cash and another cash, well, it's just an aggregation. What is an OR? An OR is a choice. In financial contract, you have sometimes the ability to make a decision. So the bank could have given the Portuguese company an option to say, I don't want to do this deal anymore. Right? That's an OR contract. And so at a specific date, the train company would have said, that's it, that's over, I don't want to continue the deal. Okay. And you have a give, which is the negation of the contract. So you can see that now you can start building a huge amount of combination of contract, and it scales. Right? You don't need to define a type and then a name, an input, and then have this common understanding on the PDF page about what is the contract. No, you have a formal definition of the contract. And what can you do after? Well, you can do a lot of things. You can explain to the train company that they are actually a very bad scenario for them. That's the number one thing you can do. You can throw random paths and then analyze how the contract behaves on those paths and say, look, in this instance, you're going to lose a lot of money. You can do Monte Carlo simulation. When you do a Monte Carlo simulation, what you do is you compile the contract into some things that can be run inside a financial model. Right? So we know how to write compilers. OCaml is good for this. And the other things you can do is you can extract meaningful information. So you can say, okay, your deal depends on X, Y, Z. Let me look at all the data that comes from X, Y, Z, and I can give you some other meaningful insight. So now, one of the things that we've added is, we did our own little language that is as well written in OCaml that allows people to construct those financial contracts on top of the basic foundational algebra that represents financial contract. And what we have there is that now we expose to the Bloomberg terminal clients a functional language, because this is itself a functional language. It doesn't have a type system, but it is purely functional in the function of first class value, no side effect. And we have now terminal users which have never had any computer science background that are actually writing functional programming to define their contract. So we hope that that we contributed a little to the adoption of functional programming concept to a crowd that we didn't know would ever use functional programming, but they actually do. And it's really surprising when you talk to a person that all it did was like a few VBA macro in Excel, and you explaining what is a fault left, a fault right, how to do accumulation, all of those kind of things, and they actually get it. It's really great to see that people are capable of applying those concepts when in their practical life. So yeah, so we provide a lot of so it is a challenge sometimes to explain to non-developers the concept of a fold, for example. But surprisingly, it's more difficult when the person is already used to a for loop. Because the first thing that they're going to ask is, where is my for loop? So then the people who have never programmed a for loop, then they see, okay, this function is from each step, this is my function. Okay, I understand the concept. And they don't get stuck on like, where is my for loop, where it's missing from my tool set. But we also, what we work a lot on is like providing helper functions to make to provide higher level financial concepts. So we keep building expertise based on their feedback about what are the functions that we want to expose. Yeah. So we try to make it easy, of course, for them. So overall, this is how we use OCaml, and we started with none of us in the team ever knew about OCaml before. So 3 years ago, we had zero OCaml experience, and then we jumped into the functional programming train. It was really good, and we love working with the guys at Lexify on their core product. We get to develop tons of other things on top of it. It's great, and we keep using it more and more. So a few lessons learned because we started from nothing. So here are some feedback from a newcomer to functional programming. So really, the first thing is the increase in productivity. Right? What we often forget when we write small projects is that C++, it compiles fast. Python, there's no compilation, but it's fast enough for my use case. But when a program compiles extremely fast, when you reach 100 files, I can tell you this is a lifesaver, right? Of course, the compilers does a lot more work for you, lot less bug. We definitely saw the trend there. It's fun as well. Honestly, like a lot of people just like it. And the code quality overall, we're writing cleaner code, right? It's much more readable. Okay, the things that we have struggled a little bit. So we are coming from the entire Bloomberg is, most of it is written in C++ and C. So the integration of OCaml with the existing library was always a challenge for us. We're getting better at it. We're using techniques to make that better. Speed. One of the problems as well is that OCaml is not supported on all of the platform that we run our software. We run software on AIX, on Sun OS, on Linux. Sun and Linux are supported, but not AIX. So of course we have to do remote calls to Linux for some of the library calls that we're making. So speed can be an issue, but OCaml is very fast. So that's at least that's good on that point. And yeah. Good coding. And also what we found a little bit hard at the beginning was to find good practice in functional programming, right? So that's something that there's a lot of literature in other languages, but really like how to scale, how to write like very large code base using functional programming, what are the good practices, when to use which tool from functional programming. That at the beginning was a little bit trial and error, but it's getting better. We can see a lot of new books coming up that are very nice and explain some of the feature. So what's next? What's next is like we try to use OCaml in different topic, to solve different problem. We try to, as an infrastructure team, to promote the use of OCaml by providing ease of development and tools for integrating with our development environment. So hopefully I'll have in the next few years, I have even better example of how we use OCaml to solve complex problem. That's it.